Hi everyone. Our project is a navigation system for AI techniques used in image pattern recognition. The subject is Research Project 32930 Autumn 2020, and our group has Edward Poon and Rakshai Vipun, that is me. Let's start with why we need this project by setting the research question. First, what are the common artificial intelligence techniques used for image pattern recognition? How can the navigation system help users to find and select AI techniques for their use? And the third is, will the system have value? The research aim is to create a navigation system of the AI techniques. For research objective, first, we collect AI techniques based image pattern recognition from academic resources such as articles or researches. Then we create a library or collection of the technique as database. Those techniques are used to develop the navigation system. It can help the user to search for technique depending on the user's purpose in the interface section. So the user can find the library via GUI or interface. It can use some functions like searching or finding to edit the collection directly. For database, we divide entities into 5 entities. Those are category, technique, novelty, technique as application area, and application area. This is the whole ERD diagram structure with different relationships in our database. For category and technique entity, the relationship between them is 1 to 0 or many, because one category can contain many techniques such as NBA and ELM. Two of them are grouped as a supervised category. Also, the category will have the ID as primary. In technique entity, it will have ID as primary key. Moreover, it contains category ID from category entity and technique ID from its entity as foreign key. For technique and novelty entity, the relationship between them is 1 to 0 or many, because some techniques such as KNN is lazy learning and single algorithm novelties. For novelty entity, we will have ID as a primary key and technique ID as a foreign key, referring to ID in technique entity. For technique entity is self-reference. It links with itself as only one-to-one. Take ANN as an example. ANN is an upgraded version by CNN. For the attributes, we identify the value based on academic papers. Accuracy max or min. We create criteria by setting the range of value at the table. Very slow, slow, average, fast, and very fast. Complexity. We determine condition by using big O notation. Thus, accuracy and complexity are to interpret in a way that users can easily understand. Computer load is computer resources using in each technique. The process is a method of each technique, and reference is a website or source that the users can get more information about each technique. Technique entity has technique ID integer as a foreign key because it refers to ID attributes in its entity. For technique and application entities, they link with many-to-many relationship. It means some techniques can be used in many application areas, such as code, can be used in short pattern recognition and decision tree application. However, some applications can be used in two techniques, like matching a pictorial structure is used in ANN and DPM. For the application area entity, it contains ID as a primary key, links to another primary key in the technique as application area entity, and that attribute is application area ID integer. In technique has application area entity has technique ID as a primary key. This attribute refers to ID attribute in technique entity. That is the end of database part. The next part is implementation. Edward will explain about it.
Cool. Thank you, Rekjai. My name is Edward Poon, and as Rekjai has mentioned before, our goal was to develop a navigation system that provides easy to digest information through a graphical user interface called a GUI from here on for any user. This prototype will search image-based pattern recognition AI techniques from a database. So what did we use? The current prototype is designed using Python 3.8 for the front end and MySQL database for the back end. The language has a low learning curve and is for the general purpose use, but in this case it is used to create a GUI to interact with the database. Python has a lot of available libraries for the GUI design and has a native API for it to interact with MySQL database. It requires no additional steps when connecting the front and the back end and retrieving the data from the database unless you want to transform the data. So our prototype had a few main requirements that needed to be fulfilled. These requirements were the GUI needs to be dynamic, therefore no hard coding the search results. The GUI needs to have a search function, and the search function has to be able to use different parameters to refine the search. And the GUI needs to be able to perform a create, read, update, and delete operation to the backend, which I will call CRUD operation from now on. The first page of the GUI lets the user simply display the data or change to other pages. The buttons that are outlined in red shows multiple features which allows the user to perform a more advanced search with restricted parameters. It also shows edit features, which is the page that is used to perform CRUD operations. And finally, edit other button is used to update background information and references for existing techniques. The drop-down bar here allows the user to select features, in other words, a column name, and then it will fire off a query that will sort the selected feature alphabetically for name, learning methods, and other features that uses strings for the display. In this new slide, features using numbers, on the other hand, show descending values when selected, as outlined in the red. For this one, the sliding scale is also used to further refine the search for accuracy by only displaying accuracy with the scale's selected values. For our search function, it is presented in the multiple features page. It is not a display, and the data that appears when a search is performed is all executed dynamically. The GUI is able to take a user input and then form a query for the database. It can also select multiple features and only display the selected features in different columns, in the table within the red outline. This outlined area in red is the table where the results show, but no search has been executed in this picture, hence it does not show anything. The execution will be shown in the following demonstration. For this demonstration, let's say we only select name and learning methods and then press search. It will only show the ID and the selected features that we have clicked to search. So let's say we type in the word hybrid in the search key function. We do that and then we press search, and then it will only search for the word hybrid in both the name and learning methods column. If we remove one of them and just press hybrid, it will only look for the word hybrid in the name column. So let's say we select everything and then we press search. We'll add 2 more and then we press search. This will show everything from the current database with the features and then populate the table. So when we choose a value range, for example, let's say an 8 for a minimum value and 5 for a maximum value, it will actually show an error and not populate the table. This is because the logic behind the GUI will show an error if the minimum value is above the maximum value. So I'll be removing some of these features and leaving only max accuracy, training time, and learning methods, just so it's easier to see for the next example. So for this example, let's choose max accuracy with a minimum value of 5 and a maximum value of 8. If we press search, it will only populate the tables with the selected features and then also show a value between 5 to 8. If we change the training time to average to very fast and search again, it will restrict the search to even smaller values. So let's say we click an outside value of 5 and 8 for max accuracy and then click search. It will only show the values that is outside of 5 and 8, but still within the values of average and very fast for training time. So all these is actually possible because all the checkbox widgets and drop-down menus, as well as the buttons, are all logically linked, which is also linked to querying the database. The Edit Features interface is used to perform the CRUD operations. The sections that is outlined in red is where the user inputs the values. All of these widgets are logically connected to the buttons outlined in red at the bottom, and they're able to grab the information from the widgets and then pass the query into the database. Finally, the table that is outlined in red will be able to get the information from the database, then display what is currently available. On this page, it performs a CRUD operation. We can actually select the values we want and type in the name we want. So for this example, I'll be using application test Edward and then giving it some random values, choosing just random values as well. And then we click add. By doing this, you can see that's been added to the database. We can also click on this to retrieve specific techniques if we want. So I'll use this application Edward again to test it. Change these values. And then we click update and it performs the update operation. However, with the preloaded test that I had uploaded on this, we can delete something and show that it's actually being deleted off the database. So if we click delete, it deletes it from the database. The reason why I'm keeping the application test here is so I can use it for the next example. For the edit other page, other information that is part of the techniques are currently placed here. The outline boxes show a basic background of the techniques, an explanation of the process, and then there's a reference section for it. The two drop boxes to the right are mapped to the search and update buttons, where you can select a name and its application before a query is executed via the buttons. So for this edit other page, we can choose specific techniques that we want, like artificial neural networks. Then we can choose the application that it's on. So I'll choose matching of pictorial structures. So when we search this, it will give us the background, the process of applying the technique, and then the reference. So in the reference section, you can actually click it and it'll open up a new link. So for the previous example, we used application test Edward. If we open this up, it will see that it's a blank slate. We can test it by just typing something in new. Then we update it, we search it again, and we see that the link is working now. If we go to another technique and search, it changes, then we go back to the test of test Edward and search it again, we can see that this has been updated and is now in the database. So what went well in this project? We can use Python as it is without downloading any APIs. Getting the data and transforming it via Python could be seen in the More Features page, where the scales using strings are given values to correspond to its position. All of the information connection between the database entities work as well. We used fuzzy terms to represent the vague values of some features. And then for the main requirements of this prototype, it is actually working. So what could we have done better? A good alternative to this is to make it into a web application using Python Flask or JavaScript. This is due to the limitations of the GUI components within the Python 3.8 designs. Planning and designing the database to get it approved early on would have made the process a lot smoother as well. Choosing the features and trying to categorize it was also difficult. For example, what is considered fast or complex will be relative to the current hardware used and the person's understanding of the AI techniques. In conclusion, we were able to search multiple features simultaneously, perform CRUD operations, and show the information from the database about AI image recognition techniques via the GUI. This was achieved by using MySQL for the backend and Python 3.8 for the front end due to their compatibility. Although alternative languages like Python Flask could have made the interface design process easier, the logic still would have remained the same. Further research into the features can be done by having a set of testing images using the same hardware, but testing different techniques. Through these can remove the use of fuzzy terms for future use. Options like selecting hardware within a certain range when comparing techniques will be necessary to see the differences. By improving the prototype, it can allow better and ease of access to information for general users and for future research due to the information being allocated into one area. Thank you for listening.